Slides now.
Yes, we can.
All right, wonderful. So thank you very much. My name is Raza Zaidi. I'm a faculty member in the Department of Pediatric Anesthesiology. And it's my pleasure to talk very briefly about my XR project, which was the development of a novel method of teaching the difficult airway using 360-degree immersive video interaction. The difficult airway basically refers to the management, basically ventilation and oxygenation of a patient when that's challenging. It's one of those true life-threatening emergencies, and it affects a lot of what I do in anesthesiology, but also specialists in the ICU and in the ENT. A little bit of background: I'm a director for simulation for the Division of Pediatric Anesthesiology, and we run about 100 in-person simulation sessions a year for our residents, which is a required part of the curriculum. And we also do a number of kind of certification simulation programs for board certified physicians as well. And COVID-19 brought an immediate and unexpected halt to all our in-person simulation sessions. And it created a major educational gap. And that's kind of what led to my interest in developing a virtual simulation curriculum. As in-person simulation allows, virtual sim does offer the same possibility for immersive interactive learning, increased realism and engagement compared to traditional text and visual diagrams, and the potential for greater retention of information and enjoyment in the learning process. Of course, it allows for a safe space to kind of practice without any risk to patient harm. But unlike in-person simulation, which requires dedicated space and scheduling of time and personnel, virtual simulation has the potential for avoiding a lot of these infrastructural challenges. And COVID-19 really revealed a lot of these limitations of in-person simulation. The idea of having accessibility to a simulation session and learning opportunity anywhere, anytime really appealed to me. I chose the Unanticipated Difficult Airway as a test virtual simulation project. It's one of the more critical and stressful emergencies faced by numerous types of medical providers. And it's truly hard to learn using just text and visual flowcharts and written algorithms, because it fails to expose the learner to all the important environmental challenges, the interpersonal communication challenges, and all the kind of crisis resource management skills that are needed to navigate successfully this type of emergency. I just have a little video here. This is going to be a passive video, and I apologize for the audio, but the viewer can pan through the scene. They can look anywhere they want. They can see all the different things happening in this case, and click on different parts of the screen and get more information in kind of navigating this emergency. The simulation does allow for questions, and so I pose some questions, and I'll pose one right here on the screen here for the viewer to kind of select what they want to do next in this situation.
What do you want to do next?
They will be able to basically decide what they want to do here, and if they choose a path that may not be the right way to go, they'll go down a negative decision, or if they choose the right method, they can perform this kind of front of neck access of the neck to get oxygenation into the patient and perform this life-saving maneuver. The video itself is a little bit jittery on your end. On my end, it was very smooth, but you can view this on a VR headset. You can use it on your smartphone and access it anywhere. Again, you can go through questions. And I was very happy with the way the test project worked out. I thought it showed some tremendous potential. And I think about moving forward with this type of technology that I can create a catalog of immersive educational experiences on a variety of critical events. We are currently working on one for the management of a OB hemorrhage and kind of all the different personnel that are involved and kind of managing that situation. But also I could see it being utilized for teaching very basic skills like putting a central line in, donning and doffing early on in the pandemic for, COVID, protocols and prior to intubation and those types of things. It provides a way to rapidly train lots of people in a short period of time. And I do like the ability to be able to interact and ask questions, this choose your adventure type of idea of creating all these different decision trees. And that's, really my project. And I was very happy to have the opportunity to share with you all. Thank you.
Everything good with your camera, Mark?
Is it showing now?
Yes, it is.
Okay. So I'll go back a slide here and then, sorry about that. Can you see it all right now, or did it?
Yes, we can.
Okay, great. So what we're trying to do with this project is looking at opportunities in clinical applications, medical education, and regulatory standards. And this is where the FDA is a critical partner in this project. And we're going to be evaluating a variety of different research capabilities between our three centers. And these include medical scenario acquisitions, using high-speed 6G connectivity for immersive telepresence, looking at AI and machine learning for predictive modeling of clinical scenarios, but then also things like human factors and imaging and displays. Some examples of things that there's expertise between our three centers will be looking at tools in XR for immersive virtual reality training, and real-time procedural guidance to help with both surgical skill maintenance and making risky procedures hopefully safer and decreasing errors. This will include a robust portfolio of training modules, several of which have already been developed, looking at in-hospital cardiac arrest, intubation, and some skills for advanced practice nursing providers. In terms of our telemedicine programs, I think as we increase our ability to transmit over higher speeds and streaming, we will be able to utilize high precision rendering in much more real time over large distances with low latency and improving challenges with bandwidth. So this will impact several of our telemedicine and teleconsulting projects, including our first in the world international mixed reality grand rounds, which we've now had 3 episodes of here, hosting here between the University of Michigan, the UK, and now Canada. This is a photo from one of our grand rounds looking at 2 collaborators, one in the UK and one here in Michigan, working together in real time with a holographic model of the heart and explaining how they would treat this complex patient.
Hey, Mark, real quick, we can't see the slides that you're presenting. Would you mind flipping your PowerPoint screen?
Okay. Can you see it now or no?
We just see your like PowerPoint, but it's not in visual mode. It's not in presentation mode.
So you should be able to put it in presentation mode, and then you can change the screen share that you're giving once you put it in presentation mode to click that screen.
Okay, let me see if I can do that. I'm sorry.
No worries. It happened to me in the last session.
Screen share, and then at the top of PowerPoint, you'll see on the one that you're actually sharing, it'll have a little button that says
Okay.
top left.
Top left.
But in the actual screen sharing session. So do you have it in presentation mode?
I do.
Right, Dylan?
Can you see it now?
It might just be best to scroll through your slides
Okay.
like this rather than bothering with presentation mode.
Okay. All right. So basically, one other area we're focusing on is looking at artificial intelligence and machine learning to do predictive modeling and assessment. This includes looking at how we can utilize medical images to really apply for deep learning techniques. This is some promising collaborative work between our two institutions to identify imaging abnormalities, and we will be testing those in the upcoming months. Here at U of M, we have several projects looking at machine learning, one involving operative entrustment of surgical residents, which Taylor's going to talk a little bit about, as well as some new collaborations with Microsoft and Apocular, looking at how we can use some AI to better evaluate patients with congestive heart failure in the community, as well as how to better size aortic grafts at emergent point of care when patients come in with an aortic emergency. And then in terms of our programs here at Michigan, we kind of divide things into simulation education, telemedicine, and then these AI ML opportunities. And our pilot projects that we're really going to focus on in the first year of this grant are going to be looking at some data-driven assessment methods for surgical entrustment using joint visual attention. And this is a pilot study first that's going to then be scalable and be able to implement and validate using real world laparoscopic cholecystectomy type surgery. Taylor is going to talk a little bit about that as well. And then we have another project on virtual reality for cardiac resuscitation that Mike Cole has been running, a procedural 3D modeling acquisition for guidance of congenital cardiac catheterization, and then transforming nursing education with the HoloLens and Uptail using 360 VR platforms that Deb Lee has been championing, and Michelle Abersol. So those are some of the pilots that are going to be evaluated through this grant mechanism, and we're excited to move that forward over the upcoming year. So thank you very much for the opportunity to speak today, and look forward to the rest of the presentations.
All right.
Okay.
Should be you up next.
Does it say it should be me or should be Mike? I thought it was Mike. I can go. You need me too?
Oh, maybe it is Mike.
Yeah, I think Mike's up next.
Apologies. Well, if Mike vanished, then
I know that he was having some tech issues and was kind of coming back and forth.
I recall that as well. So maybe it would be best if you went so we can keep things moving along. We do have only 12 minutes left in the session.
Sure, sounds good. I can do that. Oh, he said his browser crashed. He just texted me. He's hopping back on.
Oh, no.
I can present in the meantime, though. That's fine.
Okay, awesome.
All right, great. So You guys should be able to see my PowerPoint slides now, correct?
Yes,
Amelia? Awesome, great. So as Mark mentioned, I'm Dr. Taylor Canner. I'm with the Center for Surgical Innovation. I'm the CSI fellow. I'm actually one of the cardiac surgery residents currently on my academic development time, and I also serve as the Resident Promise Innovation Director here at Michigan. And so I'm going to talk a little bit about the GME award that our CSI was able to achieve. It was a $100,000 award that's mainly focused on utilization of novel telemedicine devices to help enhance summative entrustment in senior surgical residents, essentially trying to allow residents to have more autonomy in the operating room to hopefully show an increased level of competency when they complete their residency training. So we've actually partnered with several industry partners that I'll kind of talk through. This is a specific partnership with Iristic. And we have several additional use cases that we propose with them. They've been a fantastic partner to work with, but you can see two of the devices that they utilize on the right side, one that's worn like a standard set of glasses and another one that's worn as a head-mounted device. That's the one that we will be using in the OR. And then here's just a quick video clip of some demo examples of what we take. And this is a very early stage development. So we're actually doing our first surgical OR cases on May 2nd that we have 3 different videos for. There's going to be a little graphic video that comes up after this where we were showing some training in the anatomy lab. So if you're squeamish, feel free to look away. But it's going to go through a dissection in terms of what you can all see in the different components, the median nerve bundle there. So this is the type of quality imaging that we're going to be able to get in the OR, and that a faculty physician can actually remove themselves from being an assistant in the operation and can even be remote. So they can either be at a computer, next or inside the room, or they can actually be remote in their office watching a senior surgical resident perform an operation, allowing them to have more autonomy while doing so. Our next project is in partnership with an awesome industry partner called Apocular. They're a mixed reality company, and they focus on 3D imaging and creating 3D images in mixed reality using the HoloLens 2. And so we're partnering with them to do aortic endograph mapping and basically doing endograph mapping within a mixed reality 3D environment as opposed to our typical 2D software. And so this is a proposal of what that is going to actually look like. We currently have the image that you see there in the middle in terms of the ability to actually go through and create a 3D structure of the aorta to visualize and to annotate and to measure. But the next component to that is actually automating the process and using artificial intelligence models to actually automatically segment, centerline, as well as construct the diameters for the aorta that we use for endograph procedures for endovascular operations. And that's currently underway. We're actually going to be pitching at the CVC Innovation Conference here in the next several weeks. And then the next company I'm going to talk about is GigXR. So they're another mixed reality partner of ours that works in the extended reality space. And this video is going to highlight some of the technology that we've been able to develop with them with their hollow patient scenarios. So you see Stephen McIver there on the left, who's their lead product developer. You can see some, or hear some lung sounds, hopefully, if it's coming through the audio, as they're listening to the patient. And then it's an interactive component as well. So you can actually add on adjuncts to the patient information. So he's taking vitals there and getting pulse ox. And then you can do interventions to patients as well. So he's adding on oxygen, where you can see a different change in the oxygen levels. And then we have incorporated imaging. So you're able to pull up imaging components for patients for specific pathologies. And in this case, the patient had a pleural effusion. So Stephen goes over and he puts an ultrasound on the patient. And then you'll see the ultrasound video pop up here on the right. And that is actually displaying a pleural effusion in a patient. And the next step is actually going to be turning this into procedural simulation where we can walk through and do that. So we have a great partnership with GigXR, and we're working with them on this development. And then really the last thing I want to say is I really think that extended reality is kind of the future of medicine. And so we're excited to work with these industry partners and continue to progress with them. Thank you.
Thanks so much, Taylor. Let's hope that Mike's browser is working. Otherwise, if there are any questions in the chat, in the meantime, if anyone is interested, we can chat until we know if Mike will be presenting or not. I am seeing one question here that says, how are we going to document our physical presence and participation in the critical elements of these procedures? Maybe it says asking for a friend, so maybe it's coming from a medical student or someone. Oh, apologies. But any questions at all would be very welcome. We do have 5 minutes left in the session.
Yeah, and Amelia, I did say that you're mentioning that GigXR is going to be at the in-person showcase tomorrow. So I know that their lead product management, Stephen, he's going to be there. He was the one that was in the video, as well as their David Lastman. So they'll be here.
Here we have a question. Do we have any results from the use of this technology as far as academic or performance gains?
That's a great question, Enrique. I see Deb Lee's also commenting in this chat. She's actually done studies on XR simulation procedures and has shown, she's looked at system usability scales as well as adaptability measurements and found that actually the results were favorable in that students really liked the mixed reality technology. And she's even done some studies that have shown that it has impacted their clinical training, especially with the fact that when you look at the amount of time that faculty have to be present for simulations, it's a good amount of time. And so when you're able to take faculty away from the students, they're able to progress through the simulations themselves using mixed reality and the interactive components of it. They're actually able to show a 75% reduction in faculty time, yet 100% of the participants in that simulation pass. So that's all credit to Deb Lee and the School of Nursing, but they have done several studies on that front.
Could you maybe speak more about your clinical experience working with these technologies? I know, Mark, we did the presentation for international grand rounds on the clinical usage of these. Maybe we could talk more about that.
Yeah, so I think that there's a lot of gaining interest in the international community around how we can collaborate and discuss, complex cases among experts from around the world in real time using these technologies. We've worked with both Microsoft and HoloLens, as well as several affiliate partners that have software and solutions for HoloLens with imaging. In looking at ways to take complex cases and really be able to demonstrate anatomy, thinking about surgical approach, think about differential diagnosis and things like that, and have a real conversation in real time with these experts that everyone can benefit from. So has both an educational component as well as a showcase of where the technology is at and where it can really be leveraged for telemedicine and telesurgery.
Yeah, we're actually going to have our 4th International Grand Rounds experience in the summer, where we're going to be showing how you can do that remote collaboration. I see Mike's in here, so we may be able to get him to.
Yeah, we can turn it over to Mike for the few minutes we have left.
You still having tech issues, Mike? I don't know if you can hear us.
Oh, I don't know. This platform, while this platform is very good, it is complex and requires practice. It's something that I have found in the last few weeks working with you all, trying to get this rolling.
Yeah. Mike, can you hear us? I don't think so.
Unfortunately not.
Well, what I can say is that he's working on a virtual reality project that's focused on team-based training, and it's fantastic. It's got like 100 different, components to it in terms of how you manage certain situations in a hospital system, and how each independent person that's contributed. It actually focuses on code experiences and how each individual patient within the code interacts in the different jobs that they have, and it really focuses on that team-based comprehension. So he's doing some fantastic studies on that.
Do you have a timeline if you are all planning to publish about these studies, when that might be, if that is something that may be happening in the future?
I know that Deb Lee's already been publishing stuff,
Deb will be speaking later today about her.
Yeah, she's going to be speaking at 4 o'clock, I think. So she'll talk all about that. But yeah, she's already doing the publishing. And then for the mixed reality components that we're working on with Apocular, we're planning on doing some very like basic proof of concept papers, as well as with Iris-Stick, and actually utilizing them in the OR. So we're hoping to be cranking those out within the next couple months.
Well, that's fantastic. Well, thank you all for your contributions and presentations. For this session, it is 3:59, so let's jump back to the main stage for discussions about the awesome platforms that we're using in soft skill development. Thank you all.
Thanks, Melia.